We are now going to prove the addition rule of differentiation. The addition rule says that if you've got some function u which depends on x and another function v which depends on x, and if y is the sum of those two functions, well then dy dx is du dx plus dv dx. Our starting point for this proof is the by definition of what dy dx means. So just to recap on that, dy dx is the limit as h tends towards 0 of fx plus h minus fx over h. And this is the key to prove this formula. So if you keep this formula in front of you, you can't go far wrong. And that goes for any of the first principle proofs. And what you should do maybe is label each part as a step. So step 1 in our proof would be to get fx for the formula here. Step 2 would be to get fx plus h. Step 3 is to subtract our two answers. And step 4 is to divide by h. The final step then, step 5, is to get the limit of our answer. So we'll keep those in mind as we go through the proof. So then the first step is to get the f of x. Fx is the function we're talking about. Fx stands for function of x, and the function in this question is y. So step 1 is just to emphasize that the function we're talking about, fx, is y, which is ux plus vx. So the function fx is a combination of two other functions, ux and vx. Step 2, again from our definition, step 2 is to go back and get fx plus h. And this is a matter of subbing in x plus h everywhere we see x. So it's u of x plus h plus v of x plus h, and that's step 2 done. Step 3 is to subtract our two answers, so we get the f of x plus h minus the f of x. And to save time, we can subtract up in columns. I mean, we can just take the u's together and the v's together, so it's this minus this and this minus this. So it's going to be u of x plus h minus ux, so that's subtracting the u's. And then subtract the v's. V x plus h minus vx. Step 4. Step 4 is to divide our answer by h. So divide both sides by h, and this gives us fx plus h minus fx on the left hand side divided by h equals, and we can break up the terms on the right hand side. We can just group the u's together and the v's together, ux plus h minus ux over h plus v of x plus h minus vx over h. And finally, step 5 is to get the limit of both sides. So the limit of fx plus h minus the f of x divided by h as h goes towards 0 is the limit of the two terms on the right hand side. So it's the limit as h goes towards 0 of ux plus h minus ux over h plus limit of the v's, vx plus h minus vx over h. And finally, if we look at our three terms now, when you've got a limit, this is back to the original definition, which is up here. So we can put down dy dx. So dy dx. So if you like, you can call that step 6, which is just tidying up. Step 6. So dy dx on that side. This limit, by definition, it's the same as the f. It's the exact same as the dy dx definition. The only difference is instead of the f above the line, we've got u. So that must be, instead of dy dx, it must be du dx. And the same with the v, that's dv dx. And there is the proof of the addition rule. So these 5 steps are called the steps of first principles, and the nice thing about laying out your work like this is in any first principles proof that you get in an exam, you're going to be using the same 5 steps. And so those 5 steps apply no matter what, if you're asked to prove something from first principles.